Chapter 6.4 exercises 35 to 42. This section, 6.4 of the book, has to do with polar equations. And we're going to work out the odd number problems, 35, 37, 39, and 41 from this set. In exercises 35 to 42, convert the polar equation to rectangular form and identify the graph. Support your answer by graphing the polar equation. And for these exercises, we're going to use some basic trigonometric reciprocal identities. And we're also going to use these things here, that r, or the radius, times the cosine of theta is equal to x, and r times the sine theta is equal to y. And also, in a circle, the standard general form of a circle is x squared plus y squared is equal to r squared. So these are going to help us, plus some basic trigonometric identities, reciprocal identities. So for this first problem, 35, r equals 3 secant theta. And so what we're going to do is take this r equals 3 secant theta, and we're going to divide both sides of this equation by secant theta. And on the right, we have secant theta over secant theta cancel equal 1. And on the left, we have r over secant theta is equal to 3. Well, the cosine of theta is equal to 1 over secant theta. So therefore, we can rewrite this r over secant theta as r cosine theta is equal to 3. Well, what do we know here? Okay, this r cosine theta identity we can use in this equation right here. So we can rewrite this equation as x equals 3. And what we have is an equation in rectangular form. So that's going to be it. And then the last thing it's going to ask us to do, and this is going to be a vertical line. At x equals 3. And then it says the last thing, to graph the polar equation, the calculator. So we go to our calculator, we're going to have r equals 3 secant theta. So we go to menu, and we're going to go to graph entry, and option 4, which is polar. And so our equation is r equals 3 times secant theta. So we go over here, secant, and we're going to get theta down here by this pi thing, and we go over theta like this. So we press enter, and we get this vertical line at x equals 3. Check. Next problem we're going to look at is 37. We have r equals negative 3 sine theta, and what we're going to do with this one is let me just write this r equals negative 3 sine theta. What we're going to do with this equation here is multiply both sides of this equation by r. So what we're going to get is r squared equals negative 3r sine theta. Now from the earlier problem we looked at, you might recall that x squared plus y squared equals r squared, and also that r sine theta is is equal to y. So we're going to take advantage of the substitutions here. We're going to replace r squared with x squared plus y squared. And we're going to replace, okay, we have negative 3. We're going to replace r sine theta with y. Okay, the next thing we're going to do is try to get this. It looks like with an x squared and a y squared, we have the basic fundamentals of what a circle is. And so we're going to get everything over on the left side. If we add 3y to both sides of this equation, we're going to get x squared plus y squared. And if we add 3y, we're going to get plus 3y is equal to 0. And now we're just going to complete the square with the y. Now to complete the square, what we do is we take this coefficient of 3, we divide that by 2. And this is the thing that we're going to square to get a perfect square. So we're going to take 3 over 2 squared. And we're going to add this 3 over 2, 23 over 2 squared to both sides of this equation. We're going to have x squared plus y squared plus 3y plus, we have 3 over 2 squared equals, and then we can just square out on the right side. 3 squared is 9 over 2 squared is 4. And so what we have is a perfect square now for this y. So we have x squared plus, we've now completed the square, so we can write in y plus 3 over 2 quantity squared is equal to 9/4. And identify the graph. Well, the graph, this is a circle with center at the coordinate pair 0, comma, and we have x plus 3 over y plus 3 over 2, so that's going to be negative 3 over 2. That's where the center is going to be, with radius of, what's our radius going to be? Remember, we have r squared. Well, the radius, if r squared is the right side of the equation, r is going to be this 3 over 2. So radius is going to be 3 over 2, which means that the diameter is going to be 3, which I hope will help us when we graph this equation. And to do that, we go to our calculator, Control I, add graph. So we go over and put r equals, well, to get to r, we go to menu, graph entry edit, 4, which is polar, r equals -3, and that's going to be sine theta. So sine theta. Okay, we go get that theta there and graph. Well, we have a circle certainly with a diameter of 3, and its center is at 0, comma, -3 over 2. So we have a verification. So that kind of gives us a little more comfort. So I'm going to just box in what we have here. Carefully. Okay, that's problem number 37. Problem 39, we have r cosecant theta equals 1. So this is not really in the r equals form, but what we're going to do is take this r cosecant theta equals 1 and divide both sides of this equation by cosecant theta. And so what we have left is r equals 1 over cosecant theta. Now, we might remember from our identities, I hope, that what is 1 over cosecant theta equal to? Is it equal? Sine theta. So we're going to rewrite this equation as r is equal to sine theta, which is what we're going to use to graph this thing eventually. And we're also going to multiply this entire equation by r, and for that we get r squared is equal to r sine theta. Well, we should remember, I hope, that y is equal to r sine theta. So we can say, and we can set, we know that r squared is equal to x squared plus y squared. So we change r to x squared plus y squared, and r sine theta we set equal to y. And for that, if we subtract y from both sides of this equation, we have x squared plus y squared minus y is equal to 0. And the coefficient of y is negative 1/2. So coefficient of y equals negative 1/2. Equals negative 1, excuse me. I'm kind of working ahead there. So if we take this in half and take this negative 1/2, that's what we're going to have to square on both sides of this equation to complete that square. So I'm going to bring this up and to the right and work down. And so we have x squared plus y squared minus y plus, and what I'm going to do is take this negative 1/2 squared, and we added negative 1/2 squared to the left side of the equation. We have to take completely squared negative 1/2 squared on the right side of the equation. And so working this all out, what we get is x squared plus, and now we have a perfect square here, y, and it's going to be y minus 1/2 quantity squared is equal to negative 1/2 squared is 1/4. And so in this case, our r is going to be, I believe, 1/2. Our radius is 1/2. Okay, so what we have, that's our equation, and this is of a circle with radius equals 1/2, and that circle is centered at the coordinate pair 0, comma, we have y minus 1/2, so that's going to be a plus, because we have the y minus k, circle 0, comma 1/2. So now we go back to graph. Now going back to graph, I'm going to actually graph this one right here. R equals sine theta. Or we could say R equals 1 over cosecant theta, right? Either one would get us the correct thing. I'm going to do 1 over cosecant theta since that's more original. So we go over here and we get a page here. Add graph to go to menu. We'll go to graph entry edit, polar. And so we said R equals, we're going to go to 1 over cosecant theta. And we go to this key here and go to, we have theta, press enter. And what we get here is a circle with a radius of 1/2. Do you see that? And the center of the circle is at 0, 1/2. So that certainly meets the dimension of, so the diameter is 1, everything checks out. So this will be a correct answer for problem number 39, verified by graphing. Next and last on our problem, 41, we have R equals 2 sine theta minus 4 cosine theta. So just writing this out, we have R is equal to 2 sine theta minus 4 cosine theta. And what we're going to do is multiply this entire equation by R. And when we have that, we get R squared equals 2R sine theta minus 4R cosine theta. And if we remember, we have R sine theta is equal to Y, and R cosine theta is equal to, write that out, R cosine theta is equal to X. And so replacing, we know that R squared is equal to X squared plus Y squared. So that's the left side. Now on the right side, R sine theta is Y, so we have 2Y minus 4X. And if we subtract 2Y and add 4X to both sides of this equation, on the left side minus 2Y plus 4X, we get cancellations on the right side, and we have left X squared. I'm going to put plus 4X, and then we have plus Y squared, and we have minus 2Y. And on the right side, that equals 0. Now, in completing the square for this X, if we take this 4 and divide that by 2, we're going to get 2. So we're going to have to add 2 squared to both sides of this equation to make out of this X squared, X from a perfect square. So we add 2 squared to both sides. And for this Y, we have this coefficient of Y here, which is -2. Well, -2 divided by 2 equals -1. So we're going to also have to add -1 squared to both sides of this equation, plus -1 squared. And when we do that, what we have is we have X Now let me go ahead and just write it all out before I write it as a square. We have x squared plus 4x plus 2 squared, which is 4, plus y squared minus 2y plus negative 1 squared, which is plus 1. And that's going to be equal to 2 squared plus negative 1 squared, which is 5. So what that leaves us with is the two perfect squares. We have quantity x plus 2 squared, and we have plus quantity y minus 1 squared, and that's going to be equal to 5. So what this is, I'm going to go to the right here. This is going to be a circle with radius equals, well, r squared is 5, so our radius is going to be square root of 5. It's going to be 2 point something. And it's going to be, the circle's going to be centered at the coordinate pair. We have this x form x minus h. So this is going to be negative 2, x value is negative 2, and the y value of our center is 1. So we look for negative 2, comma 1 being at our center there. And let's go ahead and graph this equation. For that, we go to the graphing calculator, Control I, and add graph. We pick the menu to pick the kind of graph we want, 3, and the type of graph we want is polar. And for this, we get r equals 2 sine theta. So we put in 2 sine, and we're going to get our theta. Oops. That's not it. That's the right key there. And that's going to be minus 4 cosine theta. So we get the theta symbol again. There we are. I hope this is right. Okay, we have a circle of radius square root of 5. That looks like it could be right. It's going to be about a diameter of roughly 5. And then our center is going to be at x equals negative 2 and y equals 1, so about right here. So that looks pretty good. So I'm going to go ahead and box in these answers as correct. Actually, I want just this bottom line here. Okay, that's going to be quantity x plus 2 squared plus quantity y minus 1 squared equals 5. Circle r equals square root of 5 centered at the coordinate pair, negative 2 comma 1. So anyway, that's the odd number problems worked out. Good luck with your even number problems. Thanks for viewing.